This is Greenland. Ice as far as the eye can see. In winter, temperatures can drop to below -50 degrees Fahrenheit. In summer, the few weeks of warmth only melt the ice on the surface. The rugged landscape is broken by huge crevices that look like inverted cathedrals of ice. What lies in the depths of these cathedrals? Beyond the seeming void, can there be life in this hostile environment? The glacier is full of unanswered questions. An ocean away, men and women were moved to find answers, to penetrate the mysteries of the ice cap and the world of the glacier. Late August, the scientific expedition arrives from the coast of Greenland. The adventure requires some 4 tons of camping gear and scientific equipment. The leader of the expedition is Janot Lamberton, a speleologist who specializes in ice caves. Team members include biologists, glaciologists, speleologists, a doctor, and even underwater divers.
Finish?
"15 people will spend 4 weeks in total isolation, relying only on their own resources for all their needs. After the helicopter leaves, everyone pitches in to set up camp. Luc Moreau, a glaciologist, has come to study the inner depths of the glacier.
Ouais, il a dû faire des études longtemps, le mec qui a inventé ce truc-là.
Janine, Janot's wife, is one of the organizers of the expedition. Alain Coutet, an algae specialist, has spent 25 years locating and studying algae all over the world, even in an ancient holy water basin in France. This is his first Arctic mission. Sandra McInnes, a microbiologist, is studying the microscopic animals of polar regions. A Cambridge researcher, she was one of the first women to set foot on a research base in Antarctica, near the South Pole. But this is her first trip to Greenland. She will work closely with Annette Grongard, a Danish researcher. The goal of the mission is twofold: to study the life that might exist in this barren landscape, and to explore the glacier's crevices. Greenland, the world's 3rd largest island, is located in the northern Atlantic. The polar circle passes right through it. Except for a narrow coastal rim where less than 60,000 people live, it is entirely covered by an ice sheet, 2 miles thick at its center. In Danish it's called Inlandsis, or inland ice. In summer the sun shines 24 hours a day, and temperatures can reach 60 degrees Fahrenheit. The melting ice creates rivers known as meltwater streams. When a river falls into a crevice, it carves out a cave called a glacier moulin, which can be as deep as 600 feet. Luc, the glaciologist, has come to Greenland to explore these gigantic caves.
There are very few places on Earth where we can actually enter glaciers and study the interior. We know quite a bit about the surface of glaciers, but very little about what happens inside. But that's where the source of glacial movement lies.
The biologists are also interested in the ice caves. They hope to find life which might be buried in the depths. During his scouting trips, Janot has selected a promising cave. He named it Minnik, after his grandson. The camp is set up nearby. This mission successfully unites scientific research and cave exploration. Janot, a world-famous speleologist, has dedicated his life to exploring caves. He and his team are here to guide the scientists down into the ice caves. But Janot also has another purpose. He is hoping to break the world record for descending into a glacier. He has already made 7 trips to Greenland. During an expedition in 1993, he set the existing record by scaling 568 feet down an ice cave. Scientific research is the priority, but Janot has his heart set on breaking his own record. As the mission begins, he is filled with anguish. In order to descend into the cave, the river must freeze. Has Janot chosen the right time of year for the expedition?
Unfortunately, we can't predict quirks in the weather. We've been coming here since 1989, and according to our calculations, the cold weather should be here soon. If we've hit it right, the river will freeze and we'll be able to descend.
The period for exploration is very short. As soon as the river freezes, the cave begins to close up. Under the pressure of its own weight, the ice becomes viscous and gummy. Within a few days, it's impossible to reach the bottom. The river that feeds into Munich is still flowing, so the cave is not yet accessible. While waiting, Luc Moreau, the glaciologist, will calculate its flow. The river has dug a deep bed in the ice, suggesting it's around 10 years old. Luc wants to establish whether it's the flow of rivers that determines the size of caves. His data will later be compared with data recorded at other glaciers. But first, the team must find a safe spot to measure the width, depth, and speed of the river. The depth must be measured in the middle of the river. Serge, one of the speleologists, will be suspended on a rope above the water, holding a pole which he'll lower to the bottom. But warmer weather means the ice surface has crumbled. The spikes won't hold properly. For extra safety, the rope is doubled. Serge is only a short distance away from the crevice. If he falls in, he will be gone within seconds, swept into the abyss. The river is 2 meters deep, just over 6 feet. The width has already been calculated. Now the rate of the water flow must be determined. The team will time how long it takes for a cork to travel 20 meters or 65 feet in the water. It takes nearly 10 seconds, and putting all the measurements together, they figure that every second, over 9,000 gallons of water surge into the ice cave, digging an ever deeper hole. Munich must be gigantic. At the camp, everyone is settling in. Patrick, one of the 2 divers, has taken over the kitchen. From the ample selection of fresh, canned, and freeze-dried foods, he prepares today's menu, cod casserole. In the lab tent, the biologists are also setting up. They want to know if life can possibly survive in these extreme conditions. To achieve this, they will take hundreds of samples from the ice. Some will be studied right here. Others will be flown back to France, Denmark, and England. At first glance, a glacier resembles a lifeless desert, but an experienced eye can detect hints of life. To locate this life, the biologists are eager to begin taking samples. The ice surface is treacherous, and the speleologists must show them how to navigate. This section of the glacier is riddled with snow-covered crevices from previous years.
You will have to be careful in choosing a route. It's a little tricky. There are several rivers running underneath this area, and we could fall right through.
Alain has discovered a large mass of algae so compact it has turned the snow black.
This appears to be pure algae. Pure because it has no contaminants or minerals mixed in. The very dark coloring we see here is probably due to the fact that there are billions of cells. There's a green part on the inside which does the photosynthesis. The purplish part is a pigment manufactured by the plant to protect itself from the cold and the sun.
In addition to algae, Annette and Sandra hope to find another form of life. Microscopic animals called tardigrades, or water bears. They focus on one feature of the ice cap, cryoconite holes. The wind carries tiny particles of dust and plant debris, releasing them here and there. The particles are gathered up by small streams to form what is known as cryoconite. Because of its darker color, the cryoconite attracts the sun's rays and melts the ice. A hole up to 3 feet deep may be hollowed out in this manner. It is in these water-filled holes that tardigrades are most likely to be found. Does this sample contain any? Only a microscope can give the answer. The on-site lab will quickly prove its worth. The samples from the cryoconite hole are placed under the microscope. There, on the edge of the slide, a tardigrade. These amazing creatures have 8 clawed feet and 2 eyes. A nerve center acts like a rudimentary brain. The orange mass in the center of the animal is its stomach. Scientists think that they feed on bacteria, microscopic algae, and vegetal debris. Everyone's thrilled to find tardigrades in this environment.
The first time you look in a new environment, it is always an excitement that what's going to be there, what are you going to find, and then to find it. And to realize that what you're looking at is something that you haven't seen before. And it builds up and builds up. I mean, it's absolutely fabulous.
I hear about the tardigrade, but it's the first time that I saw. How long you said?
0.3. 0.3 of a millimeter.
Gosh, ça fait 3/10
That's
de
300 microns.
Yeah.
I think they're fabulous. I first met them at university.
Yeah.
I was introduced to them in a course that I was being taught. And I just fell in love with them. I think they're brilliant.
So cute. Huh?
But what is particularly fascinating about tardigrades is their incredible mechanism for resisting the Arctic cold. In a few weeks, when winter comes, they will allow themselves to freeze completely, and in that state will await the return of summer.
The special thing about tardigrades is that they seemingly are able to stop to live. Accordingly to what we are able to measure today, metabolism in tardigrades really stops. They are not alive at that time, and then they can start to live again. So it poses some questions about the definitions of life and death, which are extremely interesting, and the transition between the two of them.
It's the 4th day of the expedition. Temperatures have dropped and the speed of the river in Minnick is beginning to slow down. But will it freeze in time for Janot and the scientists to descend to the bottom? The expedition team includes 2 underwater divers, Patrick and Michel. If the cave turns into a siphon, it will be their task to explore it. They're going to test their equipment in a small lake. Diving in cold water entails a number of risks, even for experienced divers. To protect their faces, they apply a coat of Vaseline. But the real concern is whether the regulators can withstand the cold without freezing up.
Qu'est-ce que ça fait quand ça gèle?
Usually, if the regulator freezes up, it'll free flow. I mean, the air will flow non-stop, and the tank will quickly be emptied. But sometimes the regulator gets stuck, closed, so you have no air at all. But usually it's free flow.
Tu t'assois, tu te déferas, quand tu auras tes palmes et que tu seras prêt.
This practice run is essential. If the divers run out of air in this small lake, they run little risk. But if their equipment breaks down at the end of an underwater tunnel, they won't have enough time to get back to the surface. They must be able to depend on their equipment. Before long, ice accumulates on the regulators. The air begins to flow non-stop. As a safety measure, The divers carry 2 independent air supplies. Patrick switches to his backup regulator. But this one could easily freeze too. Something must be done to make the equipment more reliable. The banks are steep, so getting in is a lot easier than getting out. It takes 4 people to haul Patrick out of the water. At the end of the day, the team gets a chance to relax over a good meal. Even inside the polar circle, someone must do the dishes.
Un mono de rinçage, mais il est con. Ça fait rien. Perce un autre trou de main.
A week has passed. Janot is eager to start exploring Minik's interior. The flow of water into the cave has diminished considerably. Janot and Serge decide to take a look. It is still impossible to descend any deeper. The ice spray from the waterfall represents a mortal danger, partly because it crystallizes around the rope and makes it slippery, but mainly because breathing air saturated with ice particles can cause asphyxiation. Serge and Janot examine whether they will be able to climb down.
On peut installer le réchaud.
Par contre, après la terrasse, ça tape juste en dessous de la terrasse, t'as vu? La flotte. Waouh, mais alors c'est balèze, hein.
For both Janot and the scientists, Minik seems an ideal cave, but it remains inaccessible. As the days pass, the urgency increases. Descending into a cave is crucial to the expedition. Janot has no choice. He must find another cave. In the following days, the speleologists locate a number of caves near the camp, but most still have rivers flowing into them. Luke takes advantage of these scouting trips to continue studying the relation between rivers and cave morphology. He is attempting to establish a cave classification system. Nonetheless, the goal is to find a cave that can be scaled right to its lowest point. Serge goes down this one to see if he can find a passage to the bottom. Luke warns Serge not to get under the dangerous spray.
La courbe de l'eau.
Once again, a wall of water blocks access to the depths of the cave. Janot is worried. The scientific work on the surface is progressing well, but he has promised to take the scientists into the depths of the glacier. 2 weeks have already gone by and time is running out. The search for an accessible cave must continue. With the speleologists busy looking for a suitable cave, Sandra and Alain continue their field work without the help of their guides. It's an arduous task, as snow has covered the cryoconite holes and the terrain is perilous. In addition to looking for tardigrades, Sandra seeks to gather more information about their environment and way of life. Without the constant supply of food brought by the wind from other parts of the world, the miraculous existence of the tardigrades on this desert of ice would not be possible. To determine exactly what is deposited by the snow and rain, she has set up a gathering device.
That's number one setup.
She has also developed a system to capture the particles carried by the wind. A small motor turns two glue-coated needles which intercept any particles that pass by. This way, Sandra can make an inventory of all the passing particles and maybe even tardigrades that fly by.
Flying is not a term I would use, but they can be lifted in the wind, yes, and moved around. That is one of the more common theories for how the tardigrades colonize different areas.
Even though tardigrades may be transported by the wind, the possibility that they meet up with other tardigrades to mate and reproduce is slight. In their samples, Sandra and Annette mostly find females. The reason is simple. Females can reproduce alone. This method, called parthenogenesis, means that their eggs do not need to be fertilized by males. Without the male's genetic contribution, only females are born, the exact replica of their mothers. It is only when the males participate in the reproduction process that the species can evolve. After several days of searching, Janot has finally found an opening below the surface of the glacier. The cave is smaller than Munich, but it appears to be accessible immediately. Luc has named it Louisa after his daughter. Luc and Janot prepare the cave for the descent. The greatest risk inside a cave is not falling, but getting hit by a falling block of ice. Luc and Janot will clear the way. The cave is now ready to be explored. It's narrow, but it's estimated to be at least 400 feet deep. Far beneath the surface, colossal forces are silently at work. The pillars of the ice cathedral, crushed under their own weight, become deformed and start to close. By measuring this, Luc will have an unprecedented opportunity to observe how ice behaves under extreme pressure. Luc embeds spikes in the ice as reference points. The task is not an easy one. The reaction of ice to extreme pressure has until now only been simulated in lab experiments. Observing ice under pressure is an important step towards predicting the movement of glaciers all over the world. Only the ice caves of Greenland can be penetrated deeply enough to allow for measurements to be taken. Today, the cave is 21 feet wide. Luc and Serge will return every day to monitor changes in the width of the cave. The weather worsens and the temperature drops again. Winter is on its way. Life on the ice sheet prepares for the return of extreme conditions. The tardigrades have already begun their extraordinary freezing process. In one of the last samples, Annette found a tardigrade frozen for the winter. In the lab tent, the biologists witness a miracle. Warmed by the lamp of the microscope, a tardigrade returns to life. It takes about 15 minutes for the animal to totally regain consciousness. Tardigrades can resist temperatures approaching absolute zero, that is minus 273 degrees Celsius. To prevent its cells from exploding when it is frozen, it becomes completely dehydrated. This process is practically unknown in the animal world. It's a mystery to biologists.
There is a chance that understanding how the tardigrade go into suspended animation in a cold environment could help us find a way of storing spare parts for surgery, for example. I know there are a few people who might like to store the whole human body with the chance of reviving it in the year 2021 or something like this, but I think that's probably a little bit too much science fiction.
Certain algae, like the tardigrades, also put themselves on hold until next summer. But can life remain in that state of suspended animation for more than one season? The ice at the bottom of the caves is at least several hundred years old. If the scientists can find traces of life deep within the ice, they will attempt to revive it.
N'oublie pas que c'est un... Ce que je t'ai expliqué tout à l'heure, c'est-à-dire que c'est un siège.
Alain is excited at the thought that he might discover specimens of algae that have been frozen for centuries. He decides to descend Louisa himself to choose where the sample should be taken from. But first, he needs some lessons in cave exploration. Serge shows him how to use the speleological equipment. Before venturing down into Louisa tomorrow, he'll do a trial run above the river that flows into Munich.
Okay, you got the rope, your descender. You open up, you close it. When it's closed, you can't go down any further, okay? If for some reason or other you miss something, you miss a step, nothing. Okay? Yeah, I'll wait for you at the bottom.
C'est la première fois, là.
Yeah, it's the first time. I hope it's not the last.
Like all beginners, Alain has braced his legs in apprehension. Janot's wife Janine has tried it before. She understands the trepidation that Alain is feeling. After a few moments on the ice face, Alain spots some algae. His passion for science overcomes his fear. It's a memorable night for the members of the expedition. Greenland puts on a magical display of its northern lights.
Salut tout le monde. C'est froid, hein?
Despite the bitterly cold weather, spirits are high. Today is Alain's big day. He will descend into the abyss.
Alors, près du moulin.
Alain does not have enough experience to go to the bottom of the cave, but he will go far enough to choose good sampling sites.
Quelle journée pour mourir.
Serge takes up position at the first relay point, from where he will coach Alain on his way down. The descent is a pleasure for Serge, but Alain feels differently. At moments like this, confidence in one's equipment is essential.
Oops.
Serge guides Alain from below.
Yeah, don't tense up. Nice and easy. A little further. Yeah, there you go. There you go.
Ah, c'est toi qui tires.
That's right. Okay. Do you see that niche? That's where you need to go. All right. A little further. That's it. Good, good. That's it. All right. That's good. Now get onto the step. You look down now. You're attached. It's okay.
Alain and Serge examine the walls of the cave. Each layer of strata represents 1 year. The darker parts correspond to summer. It's here that the chances of finding life are the greatest. Before the men return to the surface, they toast Alain's first descent with a little scotch. The sampling in the depths can now begin.
Peu d'émotion?
So, how did it feel?
Un peu, hein.
D'une part, il m'avait foutu.
Well, a little shaky. Serge gave me this handle to go down with. He said when I let go of it, I'd stop immediately. He showed me how to do it. He said, look at me, I'm suspended in thin air and I'm not moving. But for me, it didn't work. I think he oiled it this morning just to get at me.
I call from the French expedition on the escape and would like to know some information about the weather. What do you think about the next day?
On the surface, the divers prepare for another trial run in the lake. Alain will dive too. He wants to take underwater samples to be sure that he has all the types of algae in the area.
C'est quoi ça?
This is a sort of system I've rigged up to keep the regulators warm. I wrap them in a layer of insulated material lined with heated filaments. Hopefully they won't freeze up.
Alain wonders if Michel's system will work. He'll find out soon enough. He's one of the people who's going to try it out. Summer has come to an end. Temperatures are now almost always below freezing. The lake has frozen over. Patrick plunges through the hard surface into the water below. The crust turns out to be so thick that Patrick hurts his leg breaking through it. Although Alain has dived before, he has never dived in Arctic water. The others give him advice and encouragement.
Essaye de chercher la meilleure stabilité.
Alain has spotted some organic material embedded in the ice that contains algae and cryoconite. This species of algae have developed an unusual survival mechanism. They secrete a sort of antifreeze and lock themselves in a protective shell. Unlike tardigrades, they continue to live, but in slow motion. They can survive several years in this manner. Patrick tests the underwater camera. It's working well. But his regulator isn't. The heated covering didn't do the trick. Alain heats a simple glass tube to make an extremely fine pipette.
Hop. Et là, il se coupe.
And there we
Maintenant,
go.
il faut qu'avec l'un des deux, je fasse un...
With one half, I'll make a tip.
Là, j'ai un cheveu. Hein.
It's as thin as a hair.
Là, on a quelque chose
Must be
qui
about
doit être
5
d'ordre
microns wide.
de 5 microns.
He will use the pipette to separate the algae taken from the lake from the particles of cryoconite mixed in it.
C'est très joli, ces petites algues. Il va y avoir au moins 2 espèces.
There are tens of thousands of known species of algae in the world, varying in size from 1 micron to over 160 feet. Less than a dozen species live on the ice cap. Like all plants, algae produce oxygen by photosynthesis. Because of their vast quantity, they produce more oxygen than all the world's forests. Therein lies the importance of studying and protecting them. The species in Greenland are especially interesting because of their extraordinary ability to survive in extreme conditions. Also, if it is shown that certain species of algae remain in suspended animation for long periods of time, new avenues could open up for research, not only in understanding the survival mechanism, but also in using freezing techniques for the preservation of endangered species. Janot is pleased. The scientists are obtaining the hoped-for results. But Janot's personal goal remains before him. If the current cold spell continues, it will be possible to reach the bottom of the Minnick, the larger cave, in about 10 days. Janot is considering staying on longer than the scientists to try to beat his own world record. Today, he will climb down part way in order to plan his route to the bottom. Janine, his wife, knows that from now on, nothing is more important to Janot. The thrill of exploring is all-encompassing for him. She is filled with worry as she watches him descend.
I get terribly stressed out when Harry goes down a cave. I used to stay home in France, and that was even worse. It's a little bit better now that I accompany him. It helps me to stay close to him during the expedition. But still, every time he goes down, I feel sick with worry. But I need to be near him, and I think that my being there helps him too.
How does it feel to be inside?
Well, going down a cave is scary, but it's exciting too. I always think to myself, here I am, going into a place where no human being has ever been before. And that's a great feeling. It's no doubt the best part. And then there's the euphoria, the attraction of the unknown. You gotta be careful though. It's dangerous down there. It's important not to go beyond your limit.
It's now nearly 4 weeks since the mission got underway. The scientists' work of taking measurements and samples in Louisa is almost completed. Today, Annette will join Luc and Serge to supervise sampling in the depths of the cave. Every 3 feet she descends represents another 10 years of time. Halfway down, she plants her crampons in snow that fell about the time Christopher Columbus discovered America.
Just a little further now.
C'est arrivé.
Ah,
Superbe descente. Vas-y, donne du mou. Ouais.
great job.
Très bien.
The 3 know exactly what they must do, and they work quickly and efficiently. To be certain the samples will not be contaminated by dust or organisms brought down from the surface, all the instruments are sterilized. For the same reason, Luke removes the top layer of ice to reach the heart of the strata.
D'accord. Peut-être mieux que je fasse comme ça parce que sinon. Je pense qu'on a un bon truc là.
Here, the ice is over 1,000 years old. What treasures does it contain? The thawed samples will reveal the answers. They will eventually be taken to Europe for detailed analysis. But meantime, the biologists will make a preliminary examination at the on-site laboratory. The biologists are eager to examine a drop of this precious liquid.
Do you see something?
Only small
Grains.
grains mainly.
Amidst the mass of minerals visible under the microscope, they try to spot familiar shapes. This time, there seem to be traces of algae. Alain is intrigued and comes to take a look in the microscope. Algae appear in the sample. What is important for Alain is that this sample was taken in ice nearly 300 feet below the surface. The algae that is visible has not been active or photosynthesized in over 1,000 years.
Now the question is to see if it's capable of photosynthesizing again. For the moment, we don't know. We have to try putting it in a culture medium. Well, that would have to be done in the lab. We have to take the samples to the lab and place them in a culture medium in a petri dish. And then we'd see if little green spots form. If they do, it will mean the algae has maintained its vital capacities. All this is very interesting. Nobody's ever done this before.
The mission comes to an end. The helicopter will soon arrive to pick up the biologists. But Janot and several members of the expedition have decided to stay a few days longer to attempt to break the world record. If the weather is perfect, anything is possible. The scientists are happy with the results. Thanks to Janot and the speleologists, the ice cap has produced a generous yield, hundreds of measurements and samples, which will require years of laboratory analysis before their secrets are revealed. The work could result in a better understanding not only of the Greenland ecosystem, but of the limits of life. Who knows where this knowledge will lead? What applications may be made in other domains? That is the way of scientific research. Two days after the biologists leave, Janot's dreams begin to crumble. The elements are conspiring against him. In the space of a few hours, the temperature climbs from 5 degrees to 55 degrees Fahrenheit. The ice is melting everywhere. To top it all off, it's raining. Janot's world record is slipping from his grasp. The river, which had almost dried up, becomes a raging torrent. The situation is catastrophic.
Well, if this weather keeps up, there's no way we can go down. Let's talk about something else. Everybody's worried about this.
Well, the river started to flow again. We can see the spray rising.
But it could stop again as quickly as it started up. If there's a cold spell.
Come on, weather, cooperate. A few days later, the intense cold returns. But the river continues to flow swiftly. Most of the water runs underground, shielded from a quick freeze. The team cannot put off their departure indefinitely. Supplies have run out and the helicopter will be arriving soon. Janot will make one last attempt to descend Minnick.
C'est bien le bon endroit.
Okay, Janot, you can go. Hey, Janot, can you go down any further now? Can you read me? Hello? Can you go down any further?
It's pretty much impossible. There's too much spray.
Janot must accept the situation. He will not reach the bottom.
Well, I guess I have to give up. You know, in any expedition, there's the possible and the impossible. Now I'm facing the impossible. It's a barrier. It's tough. Oh, it's tough, man. Maybe I'll try again tomorrow. But I mustn't delude myself. It's the law of nature.
In the hope of getting a glimpse of the bottom, Janot throws a flare down the cave. How deep is Minnick? Probably more than 600 feet, but Janot will not find out this year. Minnick will keep its secret.